Hello, class. Today I'm going to do I'm going to continue with the test review for the first test, and I'm going over some of my write-ups, for the practice test number 1. And from the first part of the video, I realized it came to me that I didn't check the answer using the calculator. So we did it by hand in the last recording, but then I didn't double check on the calculator. So I'm going to do that now. And let me just turn the slide on. And so when we do that, this is a group frequency distribution, and we're trying to find the mean for it. And so we need to put in the first column, we need to put our midpoint. So I'm going to put a little L1 here to remind me for that. And then I'm going to put an L2 here on the frequency column. And then I'm going to input those, okay? And I'm going to just double check my key. I know I was really sleepy last time. I'm going to make sure I didn't make a mistake. But yeah, just double checking those to make sure those are correct from last time. Okay, so I'm going to go to Stat, Edit, and then go up to the top and Clear, Enter to clear data, and then go to the side here, go up to the top, Clear, Enter. Okay, and then come back to the first column, and let's have you put the midpoints in the first column. So we have 12.5, 18.5, 24.5, 30.5, 36.5, 42.5. You go to the second column, L2, and then inputs that data there. So 3, 8, 10, 2, 13. And make sure there's not a mismatch. I saw I had a mismatch. You don't want to have a mismatch. If you have a mismatch, it won't calculate it. So yeah, but you see that matches. So I'm just double checking. Looks the same. Okay. And then you're going to go to Stat and Calculate. So you go to Stat and then Tab to Calculate, and then that one variable Stats, and your list. This is where you put your midpoints in L1, and then your frequency list is L2. So come down here, and to do that, you remember you put the second button and then number 2, because if you see right on top of your number 2 key, there's a little L2 there. Okay, so you hit the second button, and then you want to hit number 2 because there's a little L2 there. See what happens? And then you just have to remember, whenever you do future calculations, you'll have to remember to clear that, because otherwise you'll make mistakes, right? You want to make sure you clear that for future calculations. This is only when you're calculating the mean of a frequency group distribution. Okay, and then hit calculate, and here is our mean, 26.5. And let's see if we can double check some of these things here. Let's see. Okay, we can double check this. See this summation of x here? See, that's this right here. Your frequency times your midpoint, 1,382. So you're able to check that. And then, yeah, you can check also this. See, 52, the data points, 52. And then here's the 26 right here, 26.57. Okay, and then you want to round one decimal place beyond how your data is. This doesn't actually give you the data, so you want to round to the same place value as the class boundaries, and that's what we said in our notes. And so your class boundaries are in the tens place, so we round it to the tens place. Okay. All right. Okay, now there was another problem that I had. We want to do another one like this. I had page 6 here, had this page. So you see we're also finding the mean, and this is another frequency group distribution, but it's more practice because here you have counting numbers, and here you have tens place. So I wanted y'all to practice that. Okay, so remember what we said about class boundaries. We said that they have to end in a 5, and they have to be 1 decimal place beyond how the data is presented. Okay, so that's what we wrote last time. They have to end in a 5, and they have to be 1 decimal place beyond how data is presented. Now you don't actually have the data, but you have the class limits. And so you can also take that, how the data or the class limits are presented. And those are presented in the tens place. So 1 decimal place beyond that is the hundredths place. So you need the hundredths place. So we're working with subtracting and adding basically 0.05. Okay. Whereas in this problem that we were doing, here we were subtracting and adding just 0.5. Here we said 1 decimal place beyond how the data is presented. We actually didn't have the data, but we had the class limits. So here we had the class limits, and the class limits are whole numbers, counting numbers, whole numbers, counting numbers. So 1 decimal place beyond whole numbers and counting numbers is the tenths place. So we subtracted and added 0.5 yesterday, or in our last video recording. Okay. Okay. So on a test, you would demonstrate this on the first one. So here you're going to 0.8 take away 0.05, and then 4.4 plus 0.05. And then you get your calculator. And remember, this you can just, let's see if you just hit clear. Yeah, you just hit clear on this one. It's when you have your tables. When you have your tables, that's when you do second quit to get rid of the tables and get this space here. But what I just had it, I also did clear, and that worked when you don't have the tables. So I usually use clear or second quit. Okay, so here I have 0.8 take away 0.05, and that gives you 0.75. And then I do 4.4 plus 0.05, and that gives you 4.45. Okay. All right, and then you would continue that. You would continue that and get, the rest of these. So you don't have to show this part anymore in the calculator. You can just say, okay, now this is 4.5 take away 0.05, and that gives you 4.45. And remember, these should match. So you can also save time if you remember that here. It's okay for the class boundaries to match. That doesn't happen. That doesn't happen here. On the class limits, it's a form of 1 increase. So 4.4, 4.5, a form of 1 point, a plus 0.1, right? Increase, okay? But that's not the same thing here on class boundaries. On class boundaries, these are identical. So you remember that, that saves you time. And then here, 8.1 plus 0.05 is 8.15. And again, see, this would have to be 8.15, and then 11.8 plus 0.05 is 11.85. So let me just double check that. So then this would be identical. Okay, then we're at 15.5 plus 0.05. 15.55. And then 19.2 plus 0.05 is 19.25. Then 22.9 plus 0.05 is 22.95. Yeah. And then if you weren't sure, these will always be identical, but if not, you could always go back to your 23 and then take away 0.05, and you see it's 22.95. So you could do that as a check also, to double check. And then 26.5 plus 0.05 is 26.55. Let me double check that. 26. Oh, it's 26.6. See that? 26.6. So you have to be careful. 26.6 plus 0.05 is 26.65. So you see, you have to be careful. One little mistake there and it throws that off. But those are your class boundaries. And like on a test, I would have, you wouldn't have to do every single row. Some of them are going to be pre-thought out for you, different, like maybe this one's given, maybe this one's given. Some of these will be given. So you're not going to have to fill out every single row. Some of them will periodically be given, but you do know how to do this, because you need to know how to fill out the ones that are blank. Then remember your midpoint, you display it for the first one. So the midpoint, you have a choice. You can either take your class limits, add them up, divide by 2. So you can take you can average either class limits or class boundaries, and you can put CB to abbreviate CB, but you do have to average either or. And maybe this one's more reliable because this was given, where these you had to calculate, but you could see that you would do 0.8 plus 4.4 and then divided by 2. So if I do that, my calculator, parenthesis, 0.8 plus 4.4, close parenthesis, divided by 2 gives me 2.6. If you wanted to do the class boundaries, you would do parenthesis 0.75 plus 4.45, close parenthesis, divided by 2, and we should get the same thing. See? Okay. And then we would calculate the others. So we do the others. So let's see if I use these 4. Parenthesis 4.5 plus 8.1, close parenthesis, divided by 2. So it looks like 6.3. And so you don't have to show this part. You already demonstrated for the first one. So this is fine here. And then parenthesis 8.2 plus 11.8, close parenthesis, divided by 2. And that looks like I'm getting 10. And then another way too, if you think this is faster, should be a pattern, I think, here. Let's see. Let me see. If I do 6.3 minus 2.6, it's a difference of 3.7. Let's see. If I do 10 minus 6.3, is that a difference of 3.7? Yeah. So if you see that, if you think that's faster, then to get the next one, you could just do 10 plus 3.7. And then here you just hit plus. That takes that answer plus and then 3.7. And then just hit plus, and then 3.7. If you think that's faster, you can do that. And then plus 3.7. So it does have that pattern. Okay. And then here, I forgot to sum these. If I sum all these numbers here, you can sum them too, but I'm supposed to get 50. You can sum those to make sure of that. And then on the last column, f times xn. So 26 times 2.6. 26 times 2.6 is 67.6. So again, you just show your work for the first one, and then the other ones you can just, you're multiplying f times xm. So then here on the calculator, you just say, okay, I'm doing now 11 times 6.3, which is 69.3, and then 4 times 10, which is 40. 5 times 13.7, which is 68.5. 2 times 17.4 is 34.8. Oh, that's nice. 1 times anything is itself. 1 times anything is itself. So that's kind of nice there. Okay. And then you got to add all these up to get this total here. Summation of that product. So 67.6 plus 69.3 plus 40 plus 68.5 plus 34.8 plus 21.1 plus 24.8. And that gives me 326.1. Okay, and you add those up. Okay, and then when you come down here to your formula here, compute the mean according to the rounding rule, include the symbol. So this is the symbol that we want you to use for the mean. And then the formula, remember the formula is this summation of this f times xm divided by little n, not capital N, little n, and then substitute this 32 or 326.1, okay, divided by n, which is 50. And then remember, when you're calculating, you have to round. Remember, it's going to have to be the same place value as the class boundaries, which is hundreds. You're going to have to round this to the hundredths. So remember, it's the same as CB. Same place value as CB. Same place value as CB. Same place value as class boundaries. Okay. Okay, so if I do this, I could do answer divided by 50, or do 326.1 divided by 50. Looks like 6.522. And I'm going to round that to the hundreds, which is right here, tens, hundreds. And then look at the rise. Is that 5 or more? Nope. So we're about 6.52. And then if you have any units, you want to record your units. The one we did last time had units, right? The one we did last time had, see, oftentimes they have it in parentheses too that helps, millions of dollars. So last time we had units, it was $ labeling. This one though doesn't have units, so percentages of foreign-born population for each of the 50 states. So yeah, if they had units, they would have had like in parentheses. So I think that's okay on this one, because I don't see anything in the parentheses. So about 6.52. Okay, and then down here it says find and justify the modal class. So the modal class, remember, the way you decide is it's got to have the largest frequency. So I look over here, which one has the largest frequency? Um, it's 26. And you either report the class limit or the class boundary, depending on what's available. So it's like if it's a multiple choice test, they'll either have the class limit or the class boundary, but whichever one has available, you look for the one with the highest frequency. So 26 is higher than these others. So you can report it as the class limit, or you can say the class boundary. So I reported it as the class limit. I put the modal class is, I put 0.8 to 4.4, and that's the class limit. But I said, or you can also report it as the class boundary, 0.75 to 4.45, and that's CB, which is the class boundary. And that represents the percentage of foreign-born people. And why? And that's because it contains the largest frequency. That's why that works. Okay. Okay, let's go to page 5 now. Okay, so here it says that the increases in cents in cigarette taxes for 15 states in a 6-month period are these numbers here. How was the raw data presented? So these are presented as county numbers, right? And the reason why they ask that is because you're going to want to use the rounding rule. You're going to want to round. Well, here this is, of course, unless they tell you to round otherwise, this one tells you to round to nearest 10,000. So unless they tell you otherwise to round to a certain place value, honor that. But one of the reasons why we kind of keep track of that is because if they say round according to the rounding rule, it's one decimal place beyond how your data was given. So your data is given as counting numbers. So then you would round to the tens, unless otherwise spoken and like otherwise specified. Like here they're saying they want you to find variance, and they want you to use this computational model. Okay. Now the quick way to find variance, and we will use it to check our answer. Um, the quick way to do it is to put your numbers in a calculator, and then you want to square the standard deviation. You square to the second power the standard deviation, and that gives you the variance. So we will definitely do that at the end to check the answer. But and then we have your multiple choice test that will also help you quickly check off which one is correct and choose that. But to get the full credit, you do have to demonstrate. See, this is worth 7 points here. So if you don't show your work, then you only get 1 point for the right choice, but you won't get credit for not showing your work. Everyone's required to demonstrate the statistics, the algebra, the statistics, the math needed. But I was just remembering when we said check your work, I think I forgot to check the previous problem again that we just did. I'm sorry, let me go back to the previous problem, this one. And what I should do is check this one on the calculator too, right? Like we did the other one. I keep forgetting that. And that's just to make sure that we didn't make a mistake. That's why you do that. So if I come over here, do you remember what we said about the L1 and the L2? So we're going to put our midpoints in L1, and we're going to put our frequencies in L2, okay? And if we look at the previous problem, that's what we did. See, midpoints L1, frequencies L2. Okay, so let's just do that. So go to Stat, Edit, come up to the top and clear, hit Enter. Tab over here, go to the top, clear, Enter, and then start putting in your L1 data and then your L2 data. And you know, you have little room on the side here, not much, but you have room on the side. You could put your calculator commands here if you feel like you need them, something to jog your memory. You can definitely put your calculator commands up here in this space. That would be allowed to do that. Okay, so put that in. I'll do the same. You can then go to L2 and put the data in. And make sure they're equally yoked. Make sure they're equally balanced so that you can get a calculation. Okay, and then go to Stat, tab to calculate, and then you want this one variable stat, so hit Enter. And then this is good. Sometimes you have to, depending on what you're doing, sometimes you have to remove this, but we're doing a group frequency distribution, and this is correct. L1 and L2, and then just hit calculate. And then what you can do is you want to check, like you can check this number, 326.1. See, that's that. You can check this number, see, 50. And then this you want to check your mean. See that right there, 6.522. And then it's just about rounding. You want to round to the same value as the data. If the data wasn't given, you round according to the um, let's see what I say. Let me take that back. You round one decimal place beyond how the data is given, right? And here the data wasn't given, and so you round according to the class boundaries, and the class boundaries is the hundredths place. Yeah, so I think I did say that here, and then I think I wrote that over here. So the class boundaries is one decimal place beyond how the data is presented. So that's how you round for class boundaries anyway, one place beyond how the data is given. If you don't have the actual data, you have the class limits. The class limits are in the tenths place. So one decimal place beyond that is hundredths. And that's why we round into the hundredths. Okay, let's go back to this problem here. Okay, let's put the data in L1. So let's enter the data in L1. And then we'll do the one variable stats on it to help us with these numbers and to help us with the formula. Oh, and you need the formula. So you want to have it on your practice test. So that way it's already, I don't expect you to memorize it. You're allowed to use this practice test. And you need the symbol, which is S squared here. That's your symbol for variance. If you want to use, yeah, we just better stick with it. Let's just stick with S squared for that, okay, for variance, okay? And then here's your formula. N times this summation of x squared, take away summation of x quantity squared, all over n times n minus 1, okay? All right, so we put the data in here, go to Stat, Edit, come up here to the top. We go to the L1, clear. Okay, let me put this data in. And really, I guess what we really should do is, every time you type a number, really, this is where you should check, right? Instead of after the fact. Really, once you type that in, you should check that. Okay. And then we're going to go to stat, calculate, and then one variable stats. And this is where you have to be careful on a test. You put your data in L1, but you don't need this anymore. A while ago, we were finding the mean for group frequency distribution, so we did need to put the frequencies in L2, but see, we're not doing that anymore. So you do have to be careful. I notice on tests, that's usually what people do. They make a mistake. They forget to get rid of that and then calculate. And then I should be able to grab some things from here, like n is 11 from the calculator. And then you can see here, summation of x, you can see is 465. So just double checking that. I got that over here too. And you can also see summation of x squared is 24, wow, 24,283. Okay. So what this is doing is it's doing 70 plus 12 plus and so on and so on. Where what this is doing 70 squared plus 12 squared plus so on and so on. That's what's happening from these numbers, okay? Okay, now we're going to do the substitution. So n was 11, see, 11 times summation of x squared, okay? So that's this big number. That's the big number here. This will always be bigger than this. It's the big number. 24,283 minus 465 squared all over 11 and then 11 minus 1. Okay. Okay, so then on my calculator, and I don't even think I have to clear this. If I just hit 11, I think it clears itself. I want to do 11 times 24,283, and that gives me this number here. And then I'm going to take 465 squared. So here's my squared key right there. Okay, it gives me 216,225. And then 11, take away 1 is 10. And let me just see what 11 times 10 is. That's equal to 110. Okay, that'll save me a little bit of time there. Okay, so then now I'm gonna, if you're gonna put all this in the calculator, if you're gonna put all this in the calculator, all one keystroke, then you need to make sure you put parentheses. And otherwise, I just do it in pieces like this. So now I do 267,113, take away 216,225, and that gives me like 50,000. What is that? 888 divided by 110. Divided by 110. 462.6181818. And remember here, variance is units squared. See the squared? It's units squared. So our units was, see, it's in cents. See, it's in cents. Anything usually in parentheses is helpful. So this is cents squared. And then they told us here they wanted us to round to nearest 10,000. So if I follow that, tens, hundreds, thousands, 10,000s, right? Tens, hundreds, thousands, tens, hundreds, thousands, 10,000s, right? Tens, hundreds, thousands, 10,000s. And then if I look at the neighbor, is this 5 or more? Yep, it's an 8, so add 1 to it. So it's about 462.6182 cents squared. Okay. 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 Now, if we were kind of going to check this on the calculator, what we would do is you would go back to stat, calculate one variable stats, and go back to calculate these numbers. And see this S of X? If you wanted to do a quick check to check that, you take the S of X and then you square that. So you take your S of X and then you square it. So S of X is 21.506066. And remember, this is going to be just cents. And then you're going to square that. So you see this x squared key here? Right here? X squared key. So oops, I didn't type the number in though. Sorry. So let me type the number in. And then square it. Okay. And then it becomes cents squared because cents times cents is cents squared. Yeah. See that? And you see, you feel confident. See, that's pretty close to this. Yeah, that's pretty close to that. So that would be the purpose, like why I would have you go all out to 10,000 so that when you do a check like that, you can see those numbers at the end there. That's one reason. Okay. And then the bottom, what we're doing, oh, we're finding the standard deviation. Okay. So now we're finding the standard deviation. And I had that on the calculator. So on the calculator, you saw me pull that up, S of X. That was the standard deviation. That was this, remember? So we should get something pretty similar to that. Find standard deviation according to the rounding rule. So the rounding rule says one decimal place beyond how the data is given. So the data is given, that's kind of why I have this, is counting numbers. So that means here you're going to want to round to the tenths place then, according to this here. And then they want you to make use of the results from 7 part A. Okay, so that was another reason why I had you go all the way out to 10,000s then. Include the symbol and the formula for the standard deviation. And then substitutions from number 7 part A. And then include correct units. Okay. So, and how was our data presented? Okay, so again, we said counting numbers is how our data was presented. Okay, so the symbol would be S of X, which is what the calculator uses, the TI-84. Or you could do little s. This is what the text uses. Okay, remember we're doing like Cheb's and empirical rule. Remember we had that formula, x equals the mean plus or minus k times s, remember, standard deviation. So the text uses s. And then the formula you could jot down is this one would be acceptable. There's a couple of formulas. There's one that's longer, but this one would be acceptable. And this was in our notes. This is the one that we put in our notes. And then you take the square root of this is your variance. And that's where it says to use your answer from 7 part A. So you want to use like you can use this one, right? We rounded to, that's why we had you round to nearest 10,000s. So if I use this one, And I think, actually, I think I used the, I think on my notes here, I used the original one. I used actually this one. So let me use the original one then, 460, so that you won't have rounding, because this one has rounding, then you round again, like rounding errors, you have buildup. So that way you don't have buildup. That's the beauty of this, is you don't have buildup. And this was cents squared. So you see when you take the square root of square root of cents squared, it's just cents. This is going to just give you cents. And then I'm going to take the square root. So the square root is, you want to use the second button and then back to the x squared, because the x squared has that little radical in blue. See that little radical right there in blue? And that's why you do second. So we do second, second, and then that x squared key. See right here? My finger? Whoops. Second, and then that key right here. There we go. And then type this in, 462.6181818, and then square root. And then we use the rounding rule on that, round to the tenths place. This is a tenths place. Is this 5 or more? No. Okay, and then when you double check it on your calculator, because this is standard deviation, when you double check it on your calculator, remember we went to stat, calculate, one variable stats, and then we're going to go down here, calculate, and see this. So this shouldn't be way off base. It shouldn't be way off base. It should be fairly close. See. Except this one you rounded. Okay. So then you feel comfortable that you did this right? This method right. And then I also had written it here to check that. Okay. So that's what this problem is about. So you just work on your speed, and then you just practice, because you have 110 minutes to do this test. So the thing is, you do have to practice, like do it a couple of times, have your notes handy, and then don't get confused. Sometimes, because I let y'all use their review, sometimes you jot down numbers from your review on accident. So make sure you focus on the problems numbers, on crunch the numbers from the test, not from the review again. So just be careful. Those are mistakes that people make when they're pressed for time. Okay, then let's go to the next page here. So the group data with the provided class boundaries represent the automotive fuel efficiency of 30 automobiles tested for fuel efficiency. Oh, here's your unit. See your units in miles per gallon. The following frequency distribution was obtained. Complete the table. Okay, so complete the table. It's almost complete, isn't it? It's almost complete. The only thing that's missing is this. So so when you add all those up, you should get 30 when you add them up, okay? But other than that, it looks like it's complete. These are class boundaries, right? The N and 5, okay? And then how was the data presented? So the data would have been presented as counting numbers. Even though you don't see it, the data would have been presented as counting numbers. And then these, the class boundaries, remember these N and 5. And then remember it's one decimal place beyond, remember how data was presented, remember? So when you think that through, um, it would have been counting numbers, and then you round this one decimal place beyond how the data is given. Okay. So and we need this because when we round it, we are going to have to, let's see, include the symbol, the formula for standard deviation, and then it does say according to the rounding rule. So it's one decimal place beyond how the data was given. So yeah, you're going to round to the same place value as the class boundaries. So you're going to round to same place value as the class boundaries, and then we'll be good, which is tenths place. Okay, so your symbol for standard deviation, you can use S of x, or you can use S. And then the formula, we saw that, right, just previously, right? We just saw that. So that some of this is, we just did that here, right? Okay, except this was not a group frequency distribution. This was just data given, whereas this is a group frequency distribution here. And it does say group data. It doesn't say group frequency distribution, but it is. Anytime you have class boundaries and frequencies, and especially midpoints, it's a group frequency distribution. So it's a group frequency distribution. Okay. So then, and so here we're gonna just, here we are gonna use our calculator for it. So in your notes, it was very complicated. In your notes, I had the formula, so we don't do that one by hand. We do the mean by hand for group frequency distribution, but we won't trouble you with finding the standard deviation using that original formula, the long formula. We'll just do it one way using a calculator. So you just want to put your frequencies, well, your midpoints first. Put your midpoints in L1, and then again, always put your frequencies in L2, and then we'll do a stat calculate. Okay, let's do that. So go to stat, edit, clear your data. Okay, then come over here and then put your data in. So L1 is the midpoints. And then L2 is your frequency. Okay, and then do stat calculate. One variable stats. And then see here how you have to stay sharp and alert. There's your list, L1. Then look at your frequency list. You need that to be L2. So tab down and hit the second button and number 2. There's your L2, and then calculate. So when you do another calculation, you have to stay alert. You need to make sure you're going to clear that, because then you won't need it anymore. So just keep an eye on that. And then this is what we have. And we need this one, right? We're doing the standard deviation, that's S of x. You need this one. So just jot that one down, 5.07. And you can check some things, like to make sure you don't have an error. See, this was supposed to be 30, so you can just check that at least. And then remember your units, this is going to be miles per gallon. So you can do MPG, it's an abbreviation for miles per gallon. And then we're going to round this to the nearest tenths. And then look at the number to the right. Is that 5 or more? Yes, it is. So add 1 to that box digit, and that gives you 5.1 miles per gallon. And then it says, now it says compute the variance, round it to the thousandths place. Okay. And then once a symbol, and I didn't ask for a formula, I asked for the symbol here, and I did ask for the substitution and then the correct units. Okay. So then your symbol would be little s squared. Okay. And then you're going to take your standard deviation and square that. So that's remember, you're going to take all of this and square that. So don't take the round off version, because then you're going to have round off error. So take all of this by 0.074162634. This is miles per gallon, and then square that. And then you will have to type that in. 5.074162634, and then hit this little, oops, this little x squared. See that little x squared right there? Hit that, and then hit enter. Okay, you get 25 point something. Okay, so let's write that down. 25.7471264. And then this is miles per gallon quantity squared. Miles per gallon, and that's quantity squared because I got units squared on that. Okay. And then rounding, what did it say about rounding? What did it say? Did it say to use a rounding rule, or did it say to round to a certain place value? Compute the variance rounded to the thousandths place. It looks like it's asking you to round to the thousandths place. Tens, hundreds, thousands. And look at the number to the right. Is that 5 or more? No. So this stays the same. 25.747 miles per gallon squared. Okay, so yeah, so sometimes I'll ask you to do the rounding rule, and then sometimes I would just want to check on your roundings, like why does she have us round to thousands here, and why does she do that periodically here? I'm just checking that you do know how to round, and then sometimes I'm just checking that you know the rounding rule. So I do that often throughout the semester. So it's important to round. You need to learn how to round. It's important to round correctly. Okay. We're almost done. Two more pages. So let's look at what page 7 says. So for this problem, choose from the following choices to fill in the blank. We're talking about unusual data values. Unusual data values have what kind of z-scores? Okay, so the picture's worth 1,000 words. So you might remember. Let me draw it from 0 to 2 to -2. That's what I had in my notes. And you might remember me saying that if you have a z-score that falls within this range, if you have a z-score, and I'm going to do the inequality less than or equal to, and it falls between -2 and 2, if it falls in there, that's considered ordinary. If you have a z-score that falls within 2 to -2, that's considered ordinary. And if that's ordinary, then that means your data is considered ordinary, not unusual. Okay, if your z-score falls within this space here, and that's having to do with the empirical rule. A large part of your data falls, a large percentage of your data falls within this range here of this 2 to -2, related to that formula. 2 standard deviations above the mean or below the mean. And so that's why we kind of keep an eye on that. If your z-score falls outside of that, then it's considered unusual. Your data is considered unusual. Okay, so I'm going to make a note of that here. Data is considered ordinary if z scores sit within range of basically it's trapped between -2 to 2. That's the idea. So that's what this question is related to. If it's unusual data values, that means they have z-scores that are what? And that means that the z-scores would have to be either um, less than -2 out here, or greater than 2 out here. Okay, to have something unusual. Okay. Okay, so then we want uh, which test scores have the higher relative position, taking care to round your z-scores to the nearest tens. So first we want the symbol and the formula. So the symbol is z, and the formula in the numerator is, in parentheses, the data value minus the mean, in parentheses, divided by s. Okay, so x is your data value. This is your mean, x bar. And of course, S is the standard deviation. And of course, Z is a z-score. It's a standard score. Okay, Z is standard score, z-score. Okay, so when I substitute that here, a score of 3.2 on a test with this is your mean and this is your standard deviation. Okay, so I want to find the z-score. So the data value is 3.2. That's the score on this test. The mean is 4.6, so I need to subtract. And I'm going to divide it by S, which is 1.8. Okay. And in a little bit, I'll type that in the calculator. But this one, since I'm on a row here, this one, this data score is 630. And I'm going to subtract the mean, which is 820. Then we divide it by S, which is, what is that, 210? Oh goodness, and we have to do this one more time. Sorry about that. I think on the test I didn't have you do it 3 times. I think you did this on the homework, but even in class I just did 2. So I think on the test, because it does take a little while to do that. This one, the score is 41, and we're subtracting the mean, which is 53, and we're dividing it by S, which is 3. Okay, and then now I'm going to use my calculator. So I do parentheses for the first one. Parenthesis 3.2 minus 4.6 close parenthesis divided by 1.8. Oh, look at that. Okay, so it's a lot of 7s in that. I'll just do dot dot dot, but I'm going to round it. Remember it said to round to the tens place, so follow directions, read and follow directions, otherwise you get points taken off. Tens place, is that 5 or more? Yes, so add 1. So negative 0.8. Okay, so keep an eye on that. And then I'm going to plot that because see what's coming up? The score with the higher relative position. Is it going to be the 3.2 or the 630, or is it going to be the 41? And then you want to know why. And the one with the higher position is the z-score that's larger, right? The z-score that's larger would be the one with the higher position. So that's why I'm going to kind of plot it on a number line. And -1, -2, -1.5. So this is, okay, here's -0.5. So -0.8, I guess it's about right here. Okay, then over here, we're going to do parentheses, 630, take away 820, close parentheses, divided by 210. Okay, this one. So negative 0.9047. And then I'll do, put those there. Okay, round to the nearest tenths place. Look at the neighbors. Is that 5 or more? No. So negative 0.9. Okay, so that's close to -1. So that's actually about right here. So -0.5, -0.6, -0.7, -0.8, -0.9. Okay, now we're going to do this one. Parenthesis 41 minus 53, close parenthesis, divided by 3. Huh, that gives us -4. Okay, so then that's -2, -3, -4 is out here somewhere. Okay. So it looks like the larger one, it looks like this one's the larger one, right? That's larger, -0.8. These are all negative. They're all negative. The larger one is the one closest to 0, right? If they're all negative, this is the larger one. Okay. So that means, but that doesn't mean that that's the score. That's not the score. That's the Z score. But they want the test score. When they say score, they want the test score, which is goes back to this right here, x, that it's 3.2. That's what they want. 3.2. And then y, since it's related, z score is largest. You're comparing 3. If it were just 2, it would be larger, but you've got 3 things, so it's the largest. Okay, so just remember on the number line with respect to the negative side, remember that the closer that this number is to 0, the bigger it is, right? So this is larger z-score. Okay. Okay, and then last page, yay. Okay, let's see. Okay, we have data, the average weekly earnings. Find the data value corresponding to the 60th percentile. Okay, there's your keyword. Keyword is corresponding to the 60th percentile. They want the symbol and the formula and then N and P. Okay, so the formula for that is C is equal to N times P divided by 100. That was the keyword corresponding, okay? And N is how many data is 1, 2, 3, 4, 5, 6, 7. And P is this percentile. They said it was 60th percentile. That's what they told us right here, 60. Okay. And then we have N is 7 times P is 60 divided by 100. So let's see what that is. 7 times 60 is 420 divided by 100 is 4.2. Okay, and then this is one, right, where you had 2 cases. Do you remember this in your notes? You have 2 cases. One is you see a whole number, a counting number, or are you getting a decimal? And in our case, we got a decimal, so this is not a counting number. So what we have to do for that is you're going to have to round up. And 4.2 is between the integers 4 and 5. So you see when you round up, this gives you 5. Okay? All right. So it wouldn't matter, even if this had been 4.5 or 4.7, rounding up still takes you to 5. It is 4.1, 4.2, 4.3, still takes you to 5. That's how you round up. So this decimal is between 4 and 5, and you round up, it means round up to the next counting number. So you round up to 5. Okay, that means that you want to record that means that you want to record when you're finding the percentile, data value corresponds to 60 percentile. That means you want to list your data from smallest to largest, and you want that data value that's in the fifth position. Okay, so you want the data value that's in the fifth position. So you got to sort these. So remember how to sort? Remember how you do a sort? You're going to put your data in your calculator. Otherwise, you have to do it by hand. I don't know what's easiest for you. But if I put my data 743, 821, 681, 697, 503, 598, 740, and then I go to stat and I go to sort. And you want it smallest to largest, right? Smallest to largest. So ascending order. So you want number 2. So you can put number 2 here. And this would be helpful because a lot of times when people miss this, one of the reasons why they miss these type of problems is they forget to sort their data. And then where'd you put your data? In second one. Okay, second one. And then you don't have to close parentheses if you don't want. It'll still give it to you. Then go back to stat. And then go back to edit. And then let's see if it sorted it. So let me write down the data. So now I have 503, 598, 1, 2, 3, 681, 4, 697, one more, 5. That's what I need, 740. That's what I need. So I'll go and write the other ones. The other ones are 743 and 821. But the fifth one is 1, 2, 3, 4, 5. That's the fifth one, fifth position. So that means the 60th percentile is 740. Okay. So now the thing is that on your test, you don't know if you're going to get the same type where this is an example where you have to round up. You don't know if you're going to get that one or the other case. The other case is, what about when it's already a counting number? The other scenario, if C is a counting number, then you're supposed to take C and C plus 1. So the other scenario is, other scenario would be that C is just a counting number, no decimal, right? A counting number. So then you're going to take the C and the C plus 1 positions. C and C plus 1 positions. And with those data positions, so you take the data in the C position and you take the data in the next one, the C plus 1 position. And then what do you do with those two numbers? Then you average those. So you take the average of those two data values. So remember, these are data positions. So then you take the average, you add them up and divide by 2. So you can go back to your notes and look at that, or go back to your homework. But those are the two scenarios, and you're just not sure which one you're getting on the test. And so you want to be familiar with that. Okay, and hopefully it'll be this one, right? Because you have an example of that there. But there's your notes in case you have the other one. Okay, now let's see, almost done. Um, the mean of the time it takes a commuter to get to work in Baltimore is 29.7 minutes. Suppose the data distribution of commuters' time was about bell-shaped, so that means empirical rule. That's empirical rule. Okay, and that's what they're saying. Uh, somewhere here, I think aren't they asking about the formula? What statistical concept is utilized for problem number 11 based on the information given that the data's distribution was apparently bell-shaped, and knowing that such data will fall within the first, second, or third standard deviations of the mean? So when it's bell-shaped, they're asking you, like, is it the empirical rule or is it Chebyshev's? That's what they're asking you. Are you using the empiricals rule, or you're using Chebyshev's theorem? And the empirical rule is utilized here. And how did I jump to that conclusion, right? Just from, I was reading and I stopped because I saw that it was bell-shaped, okay? And the standard deviation was approximately 6 minutes. What boundaries would you expect 99.7% of the scores to fall? Include formula and substitutions in your work for full credit. Okay, so so what you should do on your paper is, because empirical rule, there's the 3 rule. Remember 68, 95, 99.7 rule. So on your paper, you should write those down, because um, you don't know that's 99.7. That's for K is 3. You don't know on the test if you're going to get, again, 99.7, or you're going to get the other percentages. The 95%, that would be K is 2, or the 68%, that would be K is 1. So you just don't know on the test. So you got to write them all down. And then on your formula, you need your formula. Formula is X, your data value, is equal to the mean plus or minus K times S. So you do need that formula there. Okay, you need that. And let's see. These are your boundaries. Your boundaries, remember, X is your data value. This is your mean, right? This is your standard deviation. Okay. And then you have your Ks here. Ks are related to your percentages. So we have, because this is 99.7, we have K is 3. So we know already that this is 3. And then the standard deviation it gave us, it was, standard deviation was 6 minutes. And what was the mean? The mean was 29.7. The mean was 29.7. And then we do one for the plus and one for the minus. Okay, one for the plus, one for the minus. Okay, so if I do the one for the plus first, do the one for the plus first. So I do, and here, see how my table, I would, if I do clear, that doesn't help. See, if I do clear, that doesn't help. I need to do second quit. So second quit gets rid of that. So I'm going to do 29.7. And I think I'll do the one with the minus first. Minus, and 6 times 3 is 18, right? So this is 29.7 plus or minus 18, right? 6 times 3 is 18. So that's minus 18. 29.7 minus 18. Looks like 11.7. That would be the small. Minutes. This is minutes. And then you can just do a second, like a copy. You can do a second enter, and it copies that back. And then just backspace, and then just change this to a plus. Change it to a plus. And hit enter. Now you get 47.7. 47.7. and that's minutes. Okay. Okay. So you can do that. Okay, so just remember to put these down because you just don't know on the test what percentage you're going to get on that. Okay, and last problem. Um, use the TI-84 to identify the 5-number summary and then calculate the IQR. And they want you to include the formula for IQR. Okay, do you remember the formula was Q3 minus Q1? You remember that? Okay, so I'm going to put the data in, stat, edit, go over here and clear, and put your little data in. There's not too many, 15, 23, 30, 11, 16, and then go to stat, calculate, hit enter. Oh, and be careful here. See, you don't want L2 in there. You don't have group frequency data, so stay alert. Clear that out of the way. Okay, and then now you keep tapping down like 1. There's your min. And then there's your first quartile, 13. 16 is your median. 26.5 is your third quartile. Max is 30. And then they want you to find the IQR. So Q3 is 26.5. Take away Q1. What was Q1? 13. So 26.5 minus 13 looks like it's 13.5. Okay. So I thought there was also something on the test about the theoretical part of that. You remember, let's see, let me see if I can remember well, like the interquartile range that, like on a box plot, the larger the IQR value, that means the more variance, varied, right? Variation. Let's see if I go back to your first page, like the variation dispersed, that your data is dispersed more, right? So the larger IQRs on a box plot would mean that your data is more dispersed. And then what was the other thing we talked about? Was the IQR, and then oftentimes, often we look at the let's see, the medians, right, on your box plot also. Okay. So I think that was, let me see if I have any other notes on that to ask about. Main thing was about the IQR. And let me just see if I have anything on here on this sheet. These are just also, be able to. These are all the things that you're doing on your test. Let me just see if I have anything here about IQR. I don't think I see anything there. Let me see. Let me just check something real quick then before I sign off. I'm just looking at my 3.4 notes, so it's just I'm just reminding myself of these figures here. But we actually covered that on one of the first problems on the first page. We actually did, remember the length of your whiskers. The longer the whisker, which side it's on, it tells you if it's left skewed, right skewed, or symmetric. But we actually did that right on the first page. I think that's what I was thinking about. I had forgotten we did that on the very first page. You have a problem like that. There was one other comment. Let's see. This is not what I'm looking for. Just a second. Oh, here was a statement that that the box plots for two or more data sets are graphed on the same axis and the distributions can be compared. Okay, yeah, so to compare the averages, we use the locations of the medians. Okay, so I mentioned the median just to compare averages. And then we did talk about the variability, the spread of the data, how it's dispersed. We use the IQRs. Larger IQRs produce more variability. Okay, so yeah, so I just want to make sure I didn't overlook that, but that was the main idea for that. All right, so good luck with your studying on your tests. Okay, meet your deadlines, make sure your homeworks are done, always with at least 60% or higher. These tests are going to be using Respondus Monitor, and we talked about that on the first video. I showed you about how to get the password and everything. All right. Okay, so good luck. I wish you much favor on your test then. Okay, take care.